Hey coders, welcome to the channel. So today we are going to see the implementation of binary search using recursion. And in case if you don't know how binary search works, then I will suggest you to go and watch this video in 1.5x speed first, and then you can take the whole out of this video. The link is in the description, or you can click on the white card shown above. So without wasting any more time, let's get started. So now let's make our binary search function. So let's define the function and let's name this bin, and this function will take 4 arguments, and the first argument will be the list in which we will search for a value, and the second argument will be the value for which we will search in the list, and the third argument will be the lower bound, and the fourth argument will be the upper bound. And if you don't know what these lower bound and upper bound means, then you can simply watch the video, and after some time you will understand that what these lower bound and upper bound means. So now let's define our binary search function. So first we will check that if the middle element of this list is equal to the value that we are searching of. So how can we define that? So we can say list at the index. To get the middle index of this list, what we can do, this L is initial will be 0, and this U initially will be the length of this list minus 1. So we can get the middle index by finding the average of this lower bound plus upper bound. So what we can do, we can say L plus U divided by 2. So this will give the middle index of our list. So now we will check if it is equal to the value that we are searching of. So if it is equal, then what we can do, we will return the index of that element. So we will return this index, the middle index of this list, and after that we will check for one more condition. We will check elif. This condition will be for that condition if the lower bound is greater than the upper bound. So if it is true, then the element that we will be searching of is not present in our list. So let's check if L is greater than U, means if the lower bound is greater than the upper bound, then it means that the element that we will be searching of in our list is not present in the list. So in that case we will return -1. So it means that our element is not in the list. And now we will having two more conditions. So let's pass elif, and those conditions will be if the list at the middle index is greater than the value that we are searching of. So let's paste this, and if the middle element is greater than the value that we are searching of, so in that case we will return the instance of this binary search method and with the different values. So the list and values will be the same, but we will change the values of this lower bound and upper bound. But in this case, if this list our in middle element is greater than the value that we are searching of, then this lower bound will be the same, but we will change the value of this upper bound, and this upper bound will be our middle element, which is this. Let's copy this and paste it here, -1. So the upper bound will be the middle element -1, as we have used the same logic to find or implement the binary search method in the previous videos. So this is for this condition, and there will be one more condition. If the element, which is the middle one, is smaller than the value that we are searching of, so let's copy and paste this here, is smaller than the value that we are searching of. So in that case what we will do, we will return the instance of this binary search function, and we will change now this time we will change the value of this lower bound. So let's pass the arguments. These list and values will be the same, and this lower bound will be the middle index, which is this middle index. Let me add brackets to avoid mistakes, +1. So this will be the value of a lower bound, and now the upper bound will remain the same. So this is our binary search function, which is implemented using recursion. So now let's call this method. So now first let's define our list. So let's say my list equals, and let me enter some random numbers in ascending order. So let's say, so we have our list with these elements. So now let's call our binary search function. So we will print, and now let's call our binary search function, and now let's pass all the four arguments. So the first argument was our list, so I will pass my list here, and the second argument will be the value that we will have to search in this list. So let's say I want to search for this 34, so I will pass 34 here, and then we will have to pass the lower bound and the upper bound. So what we can pass in the lower bound and upper bound? In the lower bound we can simply pass 0, and in the upper bound we have to pass the length of this list -1. So we will say length of my list -1. So this will be a upper bound. So now let's run the code and let's see that if our binary search function is working or not. And it says 6, means our 34 is in the index 6. So now let's try for the element which is not present in the list. So let's say I will have to find 35, and now let's run the code, and it says -1, and which means that our element is not present in the list. So our binary search function is working, which is made using the implementation of recursion, and it is under 10 lines. It uses only 9 lines. If you find today's video helpful, then don't forget to give a like, and to get this kind of interesting content regularly, subscribe to the channel. And as always, thank you for watching the video.